Hello, my name is Eugene Bryce of Bryce Energy Services, and today I'm going to do a short workshop on the analysis of half-hourly meter data, focused on the UK use of the data for billing and such things, but half-hourly meter data is pretty common throughout the world, obviously electricity meter data. So I'm going to show you how I use that data, or well, firstly extract that data and then use that data. So let's move on with the overall contents of the presentation. So as an introduction to the workshop, what is half-hourly data? So fairly basic description of it. Then costs associated with time of day, and this is very much UK specific, but may well apply in other territories. An example of data processing, so use a real life business half-hourly data and look at how we may process that data. Then using the half-hourly data, we can then apply solar and EV to that data, and I'll show you how I do that. Unfortunately, questions and discussions. This is based on a real life workshop, but at that stage I'll look to add any further details or reflect on the presentation for the online class. Obviously, feel free to drop me an email following with any particular questions you have. Delighted to respond and hear from you. So what is half-hourly data? Half-hourly data is a record of the energy used in every half-hour period of every day. Might be stating the obvious there, but we need to start with the basics. So this on the right, the image on the right here, we have two half-hourly meters, and depending on the voltage level, you certainly at above 132 kV, depending on your metering point or your contractual billing point, you may have actually 2 meters, main and backup, and it's simply redundancy, or sometimes called main and check meter, just to make sure both are reading the same, because obviously electricity is a very valuable commodity, and if you're using megawatts, the cost difference from small variances will certainly add up over the course of a year. So metering box, usually managed by a third party, connected somewhere within your equipment or your local distribution network. The meters record real and reactive power, and I'll give a bit of an explanation for that. Also, some meters will record import and export. So if you're generating on site, you may well be able to use the same meter to record export. So if you have significant solar and you're exporting, and your demand on site is less than the total solar generation midday in the summer, then you'll be in the fortunate position to export to the grid, and you may actually earn cash from that process. So an example, so from 3 p.m. to 3:30, you may use 7 kilowatt hours. From 3:30 to 4 p.m., 9 kilowatt hours. So your total kilowatt hours is simply the summation of the 7 and 9 to get 16 kilowatt hours. And just a brief example of what the terminology, it's likely on the half-hourly data you have half-hour 1 to all the way to 48, and this typically reflects half-hour 01 is from midnight to 12:30 in the morning, all the way to the last half hour starting at 11:30 p.m. So again, in the UK, we have a meter point administration number, otherwise known as an MPAN, and this it contains a number of interesting information. So we have our profile class, and there's a number of classes in the UK reflecting the type of meter and whether it's connected to a business or domestic. For half-hourly data, typically it's a 00 class, or half-hourly class. Effectively means that some modern terminology perhaps, smart meter. So the data is reported back, data collected over normally telephone network, or mobile phone network I should say. Meter time switch, basically this is whether there's any built-in rates within the meter, such as night, daytime, typically superseded by the smart meter and remote processing of time of day billing. Line loss factor, this is an interesting one. It describes the distance, or technically the losses between your meter and the DNO supply point. And that's important for people looking at in great detail at their carbon footprint. I won't linger too much on that, but line loss factor, if you have multiple meters, you may want to consider looking in detail at each meter's line loss factor. Then we have the DNO region ID. So for example, in the UK, there's about, I want to say 16 old distribution network regions. So you have Northeast, Southeast, London, areas in Scotland. These companies have been bought over, merged. So there's now about 4 or 5 distribution companies, but each of those companies manages maybe 2 or 3 of the old DNO regions. That's important because depending on which region of the country you are, some of your electricity fixed pricing will depend on that region. So for example, if you're in a remote part of Scotland, the price for electricity for fixed prices based on your kilowatts are slightly higher, simply because it's more remote and more costly for the electrical network in that area, or to reinforce it, to maintain it and such things. And these costs are dictated and agreed with Ofgem. So that's the oversight to make sure these costs remain reasonable. Finally, unique identifier. So this is the crux of it. This is your serial number. So between your DNO region unique identifier and some check digits, that is your meter number. So that's our MPAN. Just a brief one on real and reactive power. So we have, people are charged based on real power, but your capacity is based on the apparent power. So we have what we call a power triangle here, and typically if you have a lot of electrical machines on your premises, you have significant reactive power, inductive, lagging, and this gives rise to cos theta, the power factor. So if you have poor power factor, or your power factor is out with tolerances, you could be penalized on your energy bill. So ideally, you want your cos theta, power factor, to be as low as possible, or as close to this red line. So the more machines you have, like production lines, conveyor belts, electrical motors, compressors, you want to add capacitors in order to pull your apparent power closer back to this real power line. And there's a number of mechanisms, the reactive power compensation, where you have capacitors that connect into your power supply as more motors connect in. So effectively you have a push-pull situation. Let me explain that a bit better, or slightly differently maybe. We have typically a pint of beer here, and traditionally or normally the actual liquid can be described as the real power. The foam is the reactive power, and the totality of it is the apparent power. Now, ideally you only pay for the real power, but the apparent power reflects your capacity. So if you have significant reactive power, then you're consuming your available capacity, i.e. the volume of the pint here, if you like. I prefer this barge analogy because it introduces this concept of an angle here. So if you consider where is the most efficient place for that horse to stand in order to pull the barge along the canal, and the most efficient place for that horse is directly in front of it. So if you were ever in a tug-of-war team pulling on a rope, you would know that keep it a straight line. As soon as you start introducing angles, your effective power or your real power reduces, and you've increased your reactive power. So you're pulling harder but only delivering less. So the fact that our horse is on the tow path introduces an angle between the barge and the direction of travel, and that angle is similar to our power factor angle. So this horse has to deliver a bit more apparent power to overcome the reactive power of pulling the barge to the right over pulling the barge forward in the direction of travel. Bit laboured, but it's just important to understand, particularly if you are in a factory with significant machinery, conveyor belts, blowers, compressors, that you probably have significant reactive power, and that is affecting or directly related to the total apparent power you are drawing from the electrical network. So again, specific to the UK, time of day charges, whatever territory you're in, do recommend you take a look through your electricity bill to see what exactly you're being charged per kilowatt and what exactly you're being charged for capacity. So here in the UK we have 1, 2, 3, 4, 5, 6, 7, 8, at least 9 individual charges or penalties based on the kilowatt hours used, but also on your connected capacity. So somebody with a connected capacity of 1000 kVA, kilovolt amps, would be charged more over somebody with a connected capacity of 500 kVA to the grid. So for this presentation, we have things like climate change levy, which is basically a tax to support green infrastructure, feed-in tariff designed to improve renewable generation. So it's almost like to support some taxation or benefits for people with solar. Renewable obligation levied. So there's quite a few names, but effectively it's taxation to support grid upgrades. Two ones we'll focus particularly on for the UK are DUOS and CHUOS, so distribution use of system and transmission use of system. In the UK, we have National Grid, who are the transmission user system, and distribution user system is our local DNO. So transmission, distribution, and these are the charges effectively that pay for their business operations at transmission and distribution level. And these are time of day charges. So depending on when you use electricity will reflect the amount of actual money paid. So looking at the distribution, so these are our actual distribution businesses in the UK. So I don't know what I said earlier. I thought I guessed 6, but maybe 6 in the UK. In England. So this is England here, Scotland, Northern Ireland, and the Republic of Ireland. I'll just say that the Republic and Northern Ireland operate a singular grid, and Scotland and England have a overall grid from National Grid, but the Scottish grid has almost like a second level. So although the main power transmission is from Scotland to England because a lot of renewables, but the oversight for Britain, Great Britain, is National Grid. So distribution companies, so for example number 5 here, which is my local one, Northern Power Grid, is made up of 2 DNO regions. One was old Yorkshire and the other one was Northern, or Northumbria here. 7 is Western Power. So Western Power is made up of at least 3, possibly 4 old ones. We have Eastern, Midlands and Southern. So you get the idea. These are all private companies regulated by Ofgem, and over the years what was, let's say at least 16 companies have been bought and sold by their neighbours to consolidate, and ultimately we've left now with these half a dozen within the UK, or excuse me, England. So the idea is the duos costs depending on the time of day. So these are our half-hourly bands. So for each half-hourly band, you may have a different duos cost. So the idea here, or previously, is to incentivize use of electricity off-peak and disincentivize or discourage, might be an easier word to say, use of electricity during peak times. And peak time in the UK is typically between 4 p.m. and 7 p.m. So we have what we call the red, amber, green charges. Amber is effectively the waking day, so between 7 a.m. and 11 p.m. We have our red band in the middle here, between 4 p.m. and 7 p.m. and the rest of the time is effectively green charges, low use charges. For the transmission system, so mentioned before, National Grid actually has oversight of the entire British grid in terms of certainly energy dispatch, but on an operational level, in Scotland we also have Scottish and Southern and Scottish Power Energy networks here that look after the operation of the transmission system. National Grid, and in Ireland, Northern Ireland, we have Northern Ireland Electricity, who works with Southern Ireland ESB for that grid. Charging mechanism for triads, as they're known, or the TUOS system, is a bit more complicated. It looks at the peak generation, peak demand of the UK grid between the 1st of November and the end 28th or 29th of February each winter. So it looks at the 3 discrete days of maximum demand and takes an average of them applied to your electricity bill. So for example, the peak half hour could be between 5:30 and 6 p.m. Here it could be between 4 p.m. and 4:30. Here it could be between 6:30 and 7 p.m. So the average of each business with a half hourly data consumption during those very discrete half hourly periods. And for some businesses that could be between 5 and 10% of their total electricity bill. So sidestep, there is a change to how those two systems are operating. So those DUOS and CHUOS, those the distribution and transmission charges, they are changing to a more capacity-based charging rather than use charging, because a lot of businesses have been managing their energy in order to avoid the triads by, reducing consumption and such things. But also there's a general trend to the capacity of the network, because there's a lot of concern here in the UK and no doubt throughout the world about the capacity of the electricity network to support electric charging of vehicles and heat pumps and general electrification of heating. So there is a shift that rather than charge businesses for their kilowatt hours at a particular time of day, is to charge them flat rate for the total capacity they are taking from the grid. And this is why the apparent power is becoming so important and being able to manage it. So some general actions to take on your electricity bill, again UK focused, but no doubt applies to other territories. Check your electricity contract, know what rate you should be paying, is the day and night rates. Have that basic information, understand exactly how much you're paying per kilowatt and when. Check your MPAN matches your actual meter. Now this is pretty basic, but has your local electricity company got the right meter? It should be, but we have encountered instances of people being charged for the wrong meter, and a simple tick, look at your meter, look at your bill, and just make sure they're matched up. Especially if you have a multi-site, multi-meter configuration, you would be surprised that sometimes old buildings may have stray meters or wrong meters. Again, for the UK, is download your use of system charging statement. So for each region in the UK, there's particular billing rates, and you should have this use of system charging statement found on your local DNO website, and that details what you should be paying for red, amber, green, and also your triads. These charges change every couple of years, so make sure that your bill reflects the applicable charging statement. New DUOS charges apply from April. So here in the UK, this process of moving from time of day, or the balance of time of day and capacity, is changing. So April 2020, I'm recording this in July 22, so this has already happened for DUOS, and the triad charges will similarly change next year. Oh, there we go, 28th. So do keep on top of this, make sure your bills reflect your actual DNO charging. At the moment, energy prices are going up significantly, so certainly in the UK, don't be on out of contract rates, because you could be paying an extortionate amount. So there's no price cap for businesses in the UK. So your electricity company is almost free to charge whatever they like if you are out of contract. And finally, no contract rates go out of business.